Hi. I hope everyone is well. I don't think anyone else is joining. So unfortunately today we only have 1 hour to go through what we need to go through. I just want to make you guys aware that in your paper sheet they do give you your formula sheet, of which I need you guys to just use it to your maximum abilities, because the new reductions are here. You can see the double and the compound angles are definitely here. Those identities are here. The ones that are not here are the ones that we are used to by now. So by the ones that we are used to, I am talking about when you have your right angle triangle. You already know that your tan is your sine of x over your cos of x. That's something you should know by now. You know that sine squared plus cos squared is equals to 1. So those are things that are going to have to remember. Other things are your special triangles, but those you can simply put it into your calculator. I don't remember which angle it is, but on your calculator, it's going to give you the square root of 2 over 2. This is a rationalized answer. You do not expect this answer from you, especially if they say please do not use calculators. So whenever you get the square root of 2 over 2, please just use 1 square root over 2. Don't use this. They will know that you definitely use your calculator, but for the rest, you can use your calculator. There's no problem with that. So because of the time limitations, it's just going to be more of a how do we use this? What can we do here? So let's start with our compound angles. The compound angles are not angles that you're necessarily going to find when it comes to identities, simplifying things or proving that the right-hand side is equal to the left-hand side. They like to use it for just expanding, basically. I'm just going to show you a question that they got in the 2024 paper. They normally use it in this way, right? If they're going to ask you the question, the symbols might be different, but this is the type of questions that they would like to stick to when it comes to the compound part. So let's work this out. We have cos of x plus y, and they want us to use the minus in order for us to derive what the x plus means. What we need to remember is a negative multiplied by a negative would give us a positive. So we would just change this to cos of x minus a negative y. And we can just follow the expansion that they have over here, where we have cos of x multiplied by cos of negative y plus sine of x multiplied by sine of negative y. We need to understand. Okay, I'm going to stop you guys from controlling and just follow, because if you follow, there we go, fantastic, so that we don't have any problems. Okay, so From there on, we know that a negative angle is just one that's going in this direction. And we understand that cos is positive in that direction. So we would have cos of y. And we have sine. And we know that sine is negative in this quadrant. So that's just going to give us negative sine x and sine y, and we are done. Let's also look at it with regards to the next question, which is 6.1.12. They want us to prove that the left-hand side is equal to the right-hand side. We'll start with the first one here. This is a cofunction. It will give us, so first and foremost, let's remember the rule here is to start with the side that's mostly complicated. So if they want you to show that the right-hand side is equal to the left-hand side, don't start with the side that has two terms. You want to start with the side that has more terms so that you have more to work with. So in this case, we will start off with the left-hand side. This cos of 90 minus x is a cofunction of sine, and will just give us sine of x. We will let cos of y be plus, okay, so it's not going to be a plus because we have a negative sign. Whenever we have a negative angle with regards to sine, we're going to go ahead and have a negative term. So that's going to be sine of y cos of 180 plus x. It is negative in this region. Cos is definitely negative in that region. So we will have cos of x. So the two negatives multiplied each other until we got a positive in between. Okay, let's look here. We have cos of x is going to let that be. We have cos of 360 plus y. 360 just means that our angle made one revolution and it would be in the first quadrant. So we have a positive cos y. And we have the minus of 360 minus. 360 minus is in this region over here where sine is negative. So that's going to give us a negative sine of x, and we have a sine of y. Now, if we look at the bottom part over here, we would see that, forgot that x there. We would see we have exactly what we have here, which is cos of xy and sine x sine y. So we already know that this should be equal to that over there. Then we're going to go ahead and consult with our formula sheet to see which double angle does that show. So if you go to sine of a plus alpha, if you check the formula sheet there, I think I posted it here. Maybe I can just go up so that we can make reference. A plus b would definitely be sine of a cos of b plus cos of a sine of b. And that is exactly what we have here. All we have to do is just change this to around. Let's just change those before we do anything. Sine x cos y plus cos x sine y. Now it looks like the identity. So we know we can have here sine of x plus y over cos of x plus y. We already spoke about the fact that tan x is the same as sine x over cos x. So we're going to go ahead and replace that with our tan x plus y. Then we see that this is equivalency to the right-hand side. Then we can get our 6 marks. And that's how they are most likely going to examine the compound part. Okay, so since there's no question, we're going to move on to another type of question, which is finding the general solution. My tip for finding general solutions is most of the time they give you quadratic equations, just that you don't kind of see that it's quadratic, but it is a quadratic equation. It's just in a trig form. Let's look at the 6.2 that we get from the 2024 paper. So in 6.2, we're given the function, the square root of 6 sine squared minus 11 cos 90 plus x plus 7. And they want us to solve for x in the interval that is going to be between 0 and 360 if f of x is equal to 2. So the first thing we're going to do here, we're going to equate this to 2. Okay. Then we're going to square both sides. We get 4 is equals to 6 sine squared x minus 11. Now, before we move on to cos, you can see that that is a co-function. And the co-functions, again, these are reductions that you should learn. I will send some information after the classes. We have sine of x plus 7. And this is 0 is equals to 6 sine squared x minus 11 sine x. If we take 4 to the other side, that's going to give us a plus 3. Now, when I said see it as sort of a quadratic equation, you can just say let sine of x be equals to y. Therefore, sine x squared would be equals to y squared. And you can just replace it here so that your mind functions a little bit better. Only when you're done finding the values can you replace it back, as long as you said on the side that you are recognizing sine x as y for now because you want to solve. So we'll have 6y squared. Notice that I didn't use x because x is already a variable that we have there. Please don't make that mistake of using x. It's not allowed. Don't use a variable that's already there. Okay. Minus 11y plus 3 is equal to 0. We can clearly see this is a quadratic equation where a is 6, b is minus 11, and our c is 3. We can use the quadratic equation to solve for y. So y would be the negative of b plus minus the square root of minus 11 squared, 4 times a times c over 2 times 6. Okay, so we would have y is equal to minus 1 over 3, or y is equal to minus 3 over 2. So you can just now fill it back in, minus 1 over 3, or y is equal to minus 3 over 2. Now, if you were to draw your sine graph, your normal sine graph, you will note that the maximum value is 1 and the minimum value is negative 1. So a minus 1.5 will not exist. So from that, we can say this is not applicable. The only thing that's applicable is this. So I'm going to solve it like I'm solving a general solution instead of a specific. So it's specific because they said they wanted between 0 and 360. So we will first look for a reference angle. When we look for a reference angle, we don't take into consideration the sign we have there. So you'll just get the inverse of a positive 1/3, not a negative. You don't have to worry about that, giving us a reference angle of 19.47. Then we're going to look for quadrants where it is negative. That's this quadrant and that quadrant. So this is a general solution, right? But you have to find the actual solution. So for this one here, for this quadrant, we have x is equals to 180 plus k360. This is a general solution, right? Just so we're clear. And then here we'll have x is equal to 360 minus 19.47 plus k360. So what you're going to do is that you're going to change the value of k. You can have k is equal to 0. I think would make a good answer on both of them. K is equal to 0 would fall within these two boundaries where you can see the values repeating themselves. Just make k is equal to 0, then you'll find that specific solution, because this one here wants a specific solution, not a general solution. If they said they wanted a general solution, you would leave it in this way. But because of also, right, if it's a general solution, that it's an element of integers, that because they were specific where the solution should be, if you let k be equal to 0, then you will get the two solutions that exist for that negative 1.3. We're moving on to the next question that they had here. Also a trig question, but it's a small problem solving, just trying to see if you understand. And these questions are always going to be there. It's not like, oh, you can't say, oh, I didn't learn this in class. These are problem solving questions. They will always be there. Thank you. They will always be there, unfortunately. Yes, for something like this, it says consider the function g of x is equals to 4 minus 8 sine squared x. 3, calculate the value of g, the maximum value of g. First thing we're going to ask ourselves, where do we find the maximum value? Where do we find the maximum value in a sine graph? There. When x is equal to 19. So if you substitute x is equal to 90 here, you would be able to find the maximum value here, because this is a sine function at the end of the day. The maximum will always exist over here. Okay. So we're going to go ahead and substitute in the 90. Oh, wait, this one is this is a maximum value, but we have a negative in front of our graph. Do you see that? So if we were to rewrite it nicely out, so it's actually upside down. Okay, this is just moving the graph up. Okay, and we should get our maximum value there. Okay, then it says write down the smallest possible value of x for which g will have a maximum value in the interval. Again, because it's inverted, there's nothing that we are doing differently. Actually, the maximum should exist at the minimum point over there, because when you square a big number, okay, it becomes bigger, but when you square a small number, it becomes smaller. No, it's still there. Okay. Questions? Okay, so the other trig I wanted us to focus on is the triangles trig. Okay, so let us remember we have your cosine rule. And your cosine rule, A, B, C, A, B, C. We can say that C squared is equals to A squared plus B squared minus 2AC cos of C. And you can also manipulate the equation so that you get the angle instead of a length. So in this case, you would get cos of C. I would rather move cos that side and move the C to the other side where I have A squared plus B squared minus C squared over 2A. Right. Once I've found that value, then I can, to AB, sorry. Once I found that value, then I can go ahead and solve for C. We also have the sine rule that says sine C over C is equals to sine A over A and sine B over B. Again, I do believe these are in your formula sheet. Let me just, yes, the cosine rule, the sine rule, and the area rule are there. So whenever you're working with the 3D and triangles, this is the formulas you need to be looking at. And also remember that you are going to use your right angle triangle formulas, such as your A squared plus B squared is equals to C squared, and also using the fact that sine of the angle we have would be opposite over hypotenuse, cos would be adjacent over hypotenuse, and tan would be adjacent over opposite. So we have to keep those in mind. Let's have a look at a question. Okay, so here it says in the diagram, C is the foot of a vertical building. You see, I see it. And D is the top of the same building. The height of the building, CD, is 16 meters. The two observers are standing 9 meters apart at points A and B, where A, B, and C lie in the same horizontal plane. A painter is working at point E, okay, over there. On the building, the angle of elevation is 46.8. There we go. DEB over here is 122, sorry. And BCA is 105.61 degrees. Says calculate the length of AC from A to C, which is the distance between the observer at A and the foot of the building. So this one, the first one, 2 marks makes sense because we're just going to use the basic trigonometry. They want this length over here. We have an angle and we have the side CD. So we will just use that angle. That's our opposite and that's our adjacent. So we'll just use 10. So 10 of 46.85 is equal to the opposite over adjacent. So CA would be equal to AC would be equal to 10 of 46.85 16 divided by 10. And that's giving us 15 meters. Then 8.2 wants us to calculate how far printer E is from the top of the building. So the only way we can do that is if we knew, okay, we can calculate the that angle by doing 180 minus 122. Oh, we are also given this. So we can then calculate the side CB. And once we're done, we would be able to calculate that side. Okay, so let's start with this angle here. This is a straight line, so we will just have 180 minus 122, it's 58. Okay, then we can go ahead and calculate this side by using our cosine rule, which says the 90, okay, let's say AB squared is equals to CB squared minus, plus 3 AC squared minus 2 CB plus, let's just let CB be equals to X because I'm gonna want to use numbers very soon and I don't want any complications. AC cos of that 105,61. Now I want to rewrite this. It's going to give me a quadratic equation, right? Because here I will have AB as 19 squared. This is going to be X squared plus 15. I just calculated that, minus 2 of 19 times 15 and cos of 105,61. Okay, that's supposed to be X, not 19. Okay, and we're gonna end up with a quadratic equation here. So just to rewrite, we will have, I want a pen, without mistake. We will have X squared and 2 times 15 times cos of 105,61. I don't like the number. I wish it wasn't this, but more of a fraction, but it's not a fraction. So we'll just have to take it as it is. It's a negative 8,07x, and we will have the 15 squared minus the 19 squared. And that gives us this is a negative 136 is equal to 0. And we can use the quadratic equation to solve for it. Okay, and we would get a length of 8.3. Now that we have it, it's easy for us to solve for EC because we can just say this is our opposite because this is a right angle triangle. That's the opposite over the adjacent. From this, we are able to calculate EC, which gives us a value of 5.1. Now that we have EC, we are actually looking for DE because we want the length from the top to E. So DE would be DC minus EC. And that would give us a length of 10.81.